we're going to jump into the next section. So last week's material all was from section 1.1 in your book. Now we're going to jump into section 1.2. So the next about 4 or 5 days we'll be spending on the next couple sections, 1.2 and 1.3. We're going to be talking about how to describe, or how to display, quantitative distributions. So last week we talked about bar graphs, we talked about pie charts, we talked about frequency tables. Now those 3 graphical displays were all used for which type of variable? Categorical. If you have categorical variables, those are your 3 options: bar graph, pie chart, frequency table. But not every variable we address is going to be categorical. We also have quantitative variables that we're also interested in. So we need to determine how to display all of our information about quantitative variables. So today we're going to talk about 3 of the different displays we can choose: histograms, Stemplots, and Dotplots. So the first one is probably the easiest one to make as far as the 3 displays go. It's not always the most useful, just depending on the size of our sample or the size of our data set. If we get a really, really large data set, this one's kind of a pain to work with. But it's probably the simplest graph to create. It's also fairly easy to interpret as far as what it tells us and things like that. So a dot plot basically is you create a number line, so you create a scale on the x-axis, and then you take your data set, and every point you have in the data, you just mark a dot above that value on your number line. So if you have multiple answers of like 14, or you have multiple 5s or whatever in your data set, all you do is put dots above the 5 or dots above the 14, and you just stack them one on top of the next. So every dot represents a data value from the set at that particular point on the number line. So as far as creating dot plots go, you're going to start with the horizontal axis. Now this can also be done vertically, but generally when you see these drawn out, the horizontal axis is the way to go. So you're going to create a number line and label it with the variable name. So whatever variable you measured, make sure that goes on as a label for that x-axis. And then you're going to create a scale. So when you create that number line, you need to make sure your minimum value and your maximum value are accounted for on that scale. Generally, when you make that scale, you are going to go by whatever intervals you want, 5s, 10s, 1s, depending on what you're dealing with. Okay, so just kind of an up-to-you type of thing as far as how you scale it. So basically, start at the minimum, start at the maximum, get your scale created. And then after that, make a dot above each of the values on the number line for each value that corresponds to something in your data set. Okay, so create a number line, label it with the variable, mark dots above the numbers for each data value that comes from your set. So what that looks like, in the book, they go through an example. They talk about the U.S. women's national soccer team. So they said in 2012, the number of goals scored per game. So they went through all the games the U.S. women's national team played, and they counted up how many goals they scored in each of those games. So here's our data set. Now to create a dot plot. Like we said, we start with an axis, label it. What would our label have to be? Goals, number of goals scored, right? That's what we're measuring, is how many goals they scored in a particular game. So we have our label. As far as our scale, what would be the smallest value we want to make sure we have on our scale? 0, so that's our minimum. How high would we need to make sure we go? At least to 14, right? So we have to start at 0, we have to go at least to 14. We can go a little further if we would like to on the maximum side, but we have to make sure those values are accounted for. And then once we have the scale created, it's just putting dots above each of the values as we run across them in the set. So here's what that would look like overall. So as we run through, we hit 0, so we put a dot above the 0. When we look at 1 goal scored, we had 1, 2, 3, 4 different games that had 1 goal scored, so we make 4 dots above the 1, and so on. And we just continue making those dots all the way through until we've accounted for all of our values. So then we notice up here we have goals where they scored 13 and 14 goals in a game. Okay, and that's it. That's a dot plot. So create the scale, label it, make the dots above where each of your data values come in. Now, some things to note here. When you have multiple values, so like here we had 4 1s, we had 5 2s, 5 3s, and so on. When you make your dots, make sure that from value to value, you keep things consistent. You should be able to run a straight line horizontally through and make sure all your dots are lining up all the way through the graph. So you don't want 4 dots here. Like if we're drawing a number line here, we wouldn't want to have like, for this value, here's my 4 dots, and then over here I've got 5 dots, but they look like they're the same height, right? We want to make sure the magnitude of the particular dots corresponds to how many dots are in that spot. So make sure when you're making those multiple dots, you are lining them up as best you can all the way through. Does that make sense? Another thing to note here on your dot plots, when you look at the scale, notice they made a scale by 2s, okay, but they still accounted for values in between. So at 1, they just split the 0 and 2. So there's our value for 1, here's our value for 3, and so on. You can do that for any interval set. So if I had gone through and gone by 5s instead, so 0, 5, 10, and 15. As far as dot plots go, we try to break them into 1s all the way throughout. So even though I have 0, 5, 10, 15 marked, I put my dot above 0, I put my dots above 1, my dots above 2, three, and so on. So you're still going to be counting by 1s throughout. You just don't have to label 0, 1, 2, 3, 4, 5 all the way up. You can create intervals and then just put dots in between. Does that kind of make sense? Okay. So when you create the scale, just create a scale that makes sense for the number of values and how far they spread. But make sure on the dot plot, you're accounting for every single individual value. It has to have a spot on the graph somewhere. Okay there? All right. Histograms. Histograms are probably the most common display for quantitative variables. So when we look at histograms, we're creating a distribution for one quantitative variable. That's the key here. Everything we're talking about today is with quantitative variables. Now, histograms have a little bit more involved as far as creating them and making them kind of do what we want them to do. So dot plot's pretty straightforward. Make a scale, label it, put some dots on it. That's it. Histograms give us a little bit more information, and they actually are kind of a little neater, a little nicer to look at overall. And so that's why, for the most part, they're generally going to be used. When we look at histograms, have you guys ever heard of histograms or seen them utilized before? For those of you who've seen them, what do they kind of look like? They look like bar graphs, right? So a histogram looks a lot like a bar graph. We're using bars to denote counts within a certain class or bin. Here's an example. We talked last week with quantitative and categorical variables. We said if we're working with a quantitative variable, we can make it act as if it's categorical by creating ranges of values. So if we take individual data or data points and we fit them into ranges of values, we're kind of making them act more like a categorical variable. So what a histogram does is it groups together similar values into classes or bins. You might see either term utilized. So what we're looking at here, this histogram, they went back and recorded or looked at the records of every earthquake that was measured in the United States over the course of I forget how many years. So they recorded every single one and looked at the magnitude of it. So on the histogram, the x-axis is going to be your quantitative variable. So you label it with whatever variable you actually measured. Here we measured magnitude. So how big was the earthquake or how strong? You're going to create a scale, much like what you did with your dot plot. The difference is when you create your scale at this time, you're creating classes of values. So you still label it out like you would a normal number line. So magnitude of 3, 4, 5, 6, 7, 8, up to 9 here. The y-axis. The y-axis is going to be the number of counts. So how many earthquakes were in this particular range for magnitude. You can also do percentages there. If you make a relative frequency histogram, you can make those percentages. What percent of earthquakes had this particular magnitude, and so on. Now, what's happening here? Looks like a bar graph, but is doing something completely different. This bar graph, this histogram, is running over a range of values. It is constant all the way throughout. Notice also, on a histogram, the bars are touching each other. So they're going to touch because we're looking at a range of values. Where one leaves off, the other one picks up immediately afterwards. Okay? So what's happening here, when we look at these different bars, this bar right here, for instance, is telling us how many earthquakes were recorded with magnitudes between 6.0 and 6.2 on the Richter scale. So if we look here, we went from 6 to 7, but we had 5 different bars within that range of values. So they're splitting them into 0.2 on the magnitude. So then the next bar tells us how many earthquakes registered between a 6.2 and a 6.4, and so on. Notice over here we have a couple earthquakes that had very minor magnitudes. Now notice there's gaps here. What are these gaps indicating? That no earthquakes had these particular magnitudes. There were no recorded earthquakes that were between 4 and 5 on the Richter scale. So when you're making histograms, one of the things that you have to account for are gaps. You're never going to just jump from bar to bar to bar to bar every time. If you have gaps, you need to have that denoted in your picture. Those mean something specific. All right? So you're creating a continuous range of values along that x-axis, and you're just going to put bars where they exist based on the set of data that you have. Okay? So that's essentially what a histogram is. It's showing you for a range of values how many individuals fell into a given class. So we're taking our data set, we're going to break it up into classes, find the counts for each, and then create the bars accordingly. Okay? So, to make a histogram, we kind of list out the steps here. The first thing that you have to decide is how you want to divide your data up. So you're going to find your minimum value, you're going to find your maximum value, and you're going to decide, okay, based on those values, how many bars do I want to create? So you need to figure out how you want to divide your data into classes so that they all have equal width. That's the next thing. If you decide to make your first class have a width of 3, so 2, 3, or 4, the next class has to have 3 values, and then the next class has to be 3 values, and so on. So once you've decided on a width, you need to make that the same width all the way throughout your classes. Okay? Now, when you guys are working on the homework and things like that, sometimes you might get to decide that. Here's my set of data. How do I want to divide the classes up? Do I want to go by 4s? Do I want to go by 5s? And you get to choose where you start. What value do I want to start at for my first class? And then progress from there. On a test or a quiz, I'm actually going to tell you, start at this value, use this width to create the histogram. And I do that because that forces all of your graphs to end up being identical. So if you're doing it correctly, your graph should be identical to everyone else's because you're starting at the same spot, you're using the same class width, so everything should look identical. If you all got to choose your own, I could have 40 completely different histograms that I got to try and count up and make sure everything works out and looks like it's supposed to. So those I'll actually kind of tell you how to create your histogram using the classes. Okay. Once you have your classes, so you're going to list the classes out. So in their case, on the earthquake model, they would have had 3 to 3.2, 3.2 to 3.4, 3.5 or 4 to 3.6, and so on. So they would list all the classes they created and then count how many earthquakes fell into each of those ranges. So how many earthquakes were from 3 to 3.2, how many went from 3.2 to 3.4, and so on. So basically, what are you creating here? I have a range of values, a class, and I'm counting how many individuals fall into each class. What does that remind you of from last week? If I have a list of classes, and I have how many individuals fall into each class, each category. Not necessarily conditional distribution, but we'd be creating a frequency table, right? If I have a list of values and I count how many individuals fall into each of those values, I'm creating a frequency table. So here's where we have a quantitative variable. We're going to make it act like it's categorical so we can create a frequency table. And then that frequency table is going to allow us to create the overall histogram that we're actually interested in. So we're looking at frequency within each class. The last thing then is just to draw your histogram. So draw your axes, scale the axes accordingly, so make the x-axis range from your minimum value to your maximum value. Scale your y-axis so that it accounts for the highest number of counts within a specific class. And then draw your bars. So draw like you would a normal bar graph. The only difference is all of the bars have to touch each other unless there happens to be a gap. So if there's a specific class where there were 0 individuals, you would leave that as a gap on your display. Okay? So, real quick, what this would look like. Now, in this case, they've already taken it upon themselves to create the frequency table that we're interested in. So they broke whatever data they were looking into. So 0 up to but not including 5. So as soon as we hit 5, we're jumping into the next class. So 0 to 5, there were 20 individuals. From 5 to 10, there were 13. 10 to 15, there were 9. So they've gone through their set, and they've picked out how many individuals fell into each of these ranges of values. So they had 20 different answers of 0 to 5, 13 from 5 to 10, and so on, for a total of 50 possible answers. Now, as far as a histogram goes then, we would start with our axes. So, In this case, it looked like they were talking about percent of foreign-born residents. So out of the 50 states, they went through and looked at how many residents were foreign-born. So 20 states had between 0 to 5% of their residents foreign-born. 13 of the states had 5 to 10, and so on. Here we have our frequency. Okay, we need to make sure we start at 0 and pop up to 20, which was our maximum value for the count. So that's where we're getting this from. And then from there, it's just to create the bars. So from 0 to 5 down here, I'd have a bar that has a height of 20. From 5 to 10, I'd have a bar with the height of 13, and so on. So once you've taken your data and you put it into a frequency table, now you take that frequency table and create the bars on the associated histogram. Okay there? Okay. Some cautions when working with histograms. These are things that you need to be aware of as you work with histograms. So create them, describe them. We'll get into describing histograms after a little while, or a little later on here this week. First, do not confuse histograms with bar graphs. They are two completely different displays. They look the same because they both use bars, but with a bar graph, we're talking about completely separate categories on a variable. So category 1, category 2, category 3, and we have the counts. Those are all separate entities. With a histogram, the bars are touching because we're looking at one continuous range of values. Even though we're breaking it into little classes, each class is related to the one before or after it. So with bar graphs, you separate the bars every time. They're never going to touch because they're completely different categories that we're working with. With histograms, since we're looking at a continuous range of values, we need to have them touching throughout the entire range, unless we have gaps somewhere in our range of values. So those two are not the same thing. Don't confuse when they give you information. So sometimes they're going to give you a description in words, sometimes they'll give you an actual table. Don't use the counts in a frequency table or the percentages in the relative frequency table as data. What that means, if I give you that frequency table from before, so we had 0 to 5, had 20, 5 to 10 had 13, and so on, right? So they gave us all the information in a frequency table. This 20, this 13, whatever other values were in there, that's what we graphed in our histogram, correct? That's how high we knew how to make the bars. But these are not the actual data values. This is telling us that 20 states had percentages between 0 and 5. The actual data are the 20 values that fall between 0 and 5. So it might be like 1.6%, 3.7%, 4.2, 0.8, things like that. So the 20, the 13, those counts, or if we do a relative frequency, those percentages aren't the data. Those are just the counts. The data would be something completely separate. So don't confuse those two things. They're both numbers, but they mean completely different things. The third one, this one's extremely important. When you create histograms, most often you're going to be creating histograms using counts. But there are times where we may be interested in percentages when making a relative frequency histogram. Remember, relative frequency means percentages. So when you have two different sets of data, and you want to compare those sets, you're going to create a histogram for group 1, and you're going to create a histogram for group 2. Okay? When you do that, if they don't have the exact same number of data values, data points, you cannot compare counts. if group 1 had 500 individuals in it, and group 2 only had 50 individuals in it, when you go to compare those based on counts, those are going to look drastically different. Because one had 500 total individuals, the other one only had 50. The bars aren't going to match up anywhere close. So you need to calculate percentages instead. Then it doesn't matter that one group had 500 individuals, the other one had 50. Since we're comparing percentages, they can now fall on the same scale, and we can compare them head to head. So if you have two different groups that have different numbers of individuals, you need to create relative frequency histograms to compare them. You have to use percentages. Okay? And the last thing, always beware that when you get a graphical display, it might look very nice, but it might not always give exactly meaningful data. It might not be giving any information that's useful, or the people reporting it to you might be trying to misrepresent something. So that's where you're checking your scales, checking that they actually use the correct type of graph, things of that nature. So always double check and make sure that even though it looks nice, it actually is saying exactly what it's supposed to be saying. It's not misleading, it doesn't have incorrect scales, things of that nature. So just be aware of that. Your calculator will create histograms. Now, we're going to skip over this for right now because for the most part, we're not going to use this function on your calculator until we get quite a ways down the road. So if we have time at the end, we'll come back and I'll kind of show you how that looks, but we're going to be talking more about that when we get there later on in some of the later lessons. So your calculator will create histograms for you, just like a quick sketch that you can use. But for right now, we're going to be creating by hand anyway, so I'm not going to have you guys use your calculators at this point. All right, so we want to create a histogram here. So for an agility test, 4th grade children jump from side to side across a set of parallel lines. Counting the number of lines they clear in 30 seconds. Here are the scores. We want to create a histogram. Now here's one where I'm telling you what size your classes have to be and exactly where to start. This is like what you would see on a test or quiz. Start here, make this your class width. Okay? So if we start the process, the first thing we need to do is create our actual classes. So I said make them of size 3, starting at 12. So the first thing we need to do is create our frequency table. So we have our variable, which is the number of jumps they completed in 30 seconds, right? And then we're going to keep track of the counts in this case, how many kids had jumps within this particular class, and so on. So, to create our classes, it says start at 12 jumps and make it a width of 3. So that means 12 jumps, 13 jumps, and 14 jumps. Those 3 values. So when it says a width of 3, it's saying how many values do I want to account for. So 12, 13, and 14. So number of jumps, 12 to 14. For my next class, I would pick up at where? 15. So 12, 13, 14, that's class 1. 15, 16, 17 would be class 2. And then 18, 19, 20 would be class 3, and so on. You guys kind of have the gist of that? So let's create your classes. Then we need the actual count. So now we go back to the data and we actually look or count how many kids had between 12 and 14 jumps. So if we look through, here's a 12, any others that fall between 12 to 14? Okay, so one kid was between 12 and 14. Then we go through and look for 15 through 17. So 15, 16, or 17. We got a 17 here. 17 here. 16 here. Did I miss any? So 3 kids had between 15 and 17 jumps. And then we go to the next one, 18 through 20. So in 18 to 20, we got 1 there, 2, 3 again. Okay with that? And then we just continue until we get to the very top edge of our range there. Okay? So once we get our frequency table, the next step is to actually create the histogram. So we make our axes. Our x-axis would be labeled what? Number of jumps. So that's the variable we were measuring. Okay. Now, as far as labeling the x-axis, we can actually label it based on the classes we created over here. The easiest way to do that is start off with your lowest value. So we started at 12, right? So we're going to have 12 as our starting point. Now our second class picks up at what? At 15. So that's going to be my next value on the x-axis. So 12 to 15. And then my next one would be 18. And then 21. And so on, however high I needed to go. Okay? Everyone with me so far? All right, the y-axis. This would be where we have our frequency, right? Our counts, whatever you want to label it, so that we know that we're just counting up how many we have. So then we create a scale. So based on our counts, we would create a scale to make sure we have as high as we need to go. So here we'd have like 1, 2, 3, 4, up to whatever we would need. Now something to note here, when you make your scales, make sure as much as possible you are evenly distributing everything. So make the bars the same width all the way through. Again, you don't need to use a ruler or anything. Just be careful, do the best you can, be as neat as possible. Make sure they're about the same width all the way through. Once we have all that, we just create our bars. So from 12 to 15 there was only 1 kid in that group, so we create a bar there. And then from 15 to 18 there were 3, so we make a bar there. And then we go 3 here, and so on. If we had any zeros, we would just leave a gap in that particular spot and then jump to the next one and continue on as we go. Okay? The only other thing I would suggest doing here, just to make things stand out a little bit, whenever I create histograms, I tend to shade the bars a little bit so that you can see the differences. So generally what I do is I just do alternating diagonals. Just something like that to kind of make them stand out from each other. Since they're all touching and all kind of compact in there, this just kind of helps distinguish between the different values and things like that. Okay with that? Okay. Now the other thing I just want to talk about real quick, a relative frequency histogram, you will be asked to do that on the homework today. Here we have the counts. If I wanted to convert this from counts to percentages for a relative frequency, what would I need to do? Yeah, find the total number of observations I have. So I would take 1 divided by the total. That gives me my percentage. What percent of kids had that many jumps? And then I would take 3 divided by the total and so on all the way down. And then all I would do is change my scale here. Instead of counts, I would make them percentages and then create it the same way as we just did here. Okay with that? All right. Then, last type of display, Stemplots. Now, Stemplots do essentially the same thing that histograms do, But instead of just looking at bars for a class width, we actually put the exact values into the display. So we take the information, the data from our individuals, and we actually put their values into the display as part of the graph. So it works with quantitative variables. It does exactly what histograms do, or what they do, but they preserve the values. Now, one thing to note here, these are good to use with small sets of data. And you'll see why here in a second. Since we're including every individual data value in our graph, if we had 1,000 different individuals in our sample, we would have to create 1,000 different values in our graph. So if you get large data sets, you're probably going to want to use a histogram as opposed to a stem plot because they're easier to make. It's going to be a lot faster. So, stem plots. Here's what they look like. So we've got a histogram on the left. These two data sets are identical. These are saying the exact same thing. So they came from the same data. This one's just a histogram, like we just talked about how we create those. This is what a stem plot looks like. So notice they're essentially doing the same thing. Here we have 55 to 60, 60 to 65, 65 to 70. So our classes have a width of 5 there, just like they have here. This goes from 50 to 50, or 55 to 60, 60 to 65, 65 to 70, 70 to 75, and so on. So they're breaking it into classes just like a histogram does. And it keeps track of how many values fall in each. So for instance, from 80 to 84 here, there were 6 individuals that fell into that class. Or for 60 to 64, there were 4 individuals that fell into that class. The difference, here when we see 60, we have 4 individuals, but do we know what heart rates they actually had? No, we just know they were somewhere between 60 and 64. But in a stem plot, do we know each individual value? Yes, we do. So now we not only know that 4 people had heart rates between 60 and 64, but we know that 1 was 60 and the other 3 were 64. So a stem plot keeps the data values incorporated in the graph. Okay? And then the other thing with stem plots that we'll talk about here in a second to create, this key off to the side. When you look at this display, you need to tell people how to read it. When they see this 8, line 8, is that 88? Is it 8.8? Is it 8,800? Because depending on how you create your stems and leaves, they're going to mean different things. So you always have to have a key that says this is how you read it. When you see a 7 line 2, that's 72 beats per minute. So then they can go through and do that with any of the other problems. 5 line 6, 56 beats per minute, and so on. Okay? So this is going to be what a stem plot looks like. So to create them, a couple simple steps here. The first thing you're going to do is take all of your data and separate it into what we call stems and leaves. The stem is going to consist of all but the final digit. So when you create your stems, it's all but the final digit. And then your leaf is going to be the actual last digit. So depending on what your data set looks like, okay, so if this was our data set, 3 values, 120, 136, 140, the stems would be what? 12, 13, 14. I would cut off the very last digit of my values and use those as my stems. 12, 13, 14. My leaves would then be 0, 6, and 5. So I only keep the last digit for my leaf. And that works no matter what type of set you're working with. So if I were to look at this data set, what would my stems be? 7, 9, and 10. The leaves would be 6, 5, and 4. Okay? So when you're creating stems and leaves, just cut off the last digit. Everything left becomes your stem. The last digit becomes your leaf. Okay? So that's the first part. Create your stems and your leaves, and then organize your stems. So once you know what stems you need to use, what numbers you're going to use for stems, you're going to arrange them. Generally, and it doesn't really matter, you can go from smallest to largest or largest to smallest. You're still going to get the same basic idea out of it. But if you go smallest to largest, people tend to be able to read that a little bit easier. So when we said we had our stems of 12, 13, and 14, we'd start with 12 at the top, 13, and then 14. We're just going to arrange them in a vertical fashion and just list them from smallest to largest. And then we have a vertical line off to the right to separate the stems and the leaves. Okay. Next step is to write each leaf in the row to the right of its stem. So if I had like 6 different values from 120 to 129, I would list those 6 values next to my 12 stem. This is all the 120s. Anything in the 130 range would be with the stem 13 and so on. So we just figure out which values go in there, place them with that stem. Now to keep things organized, once I know which leaves go into each stem, we arrange them, and this you have to do in increasing order. So you're going to put the smallest leaf first and work your way up to the largest leaf at the end. If you have repeat values, you include every single one of the values. So even if you have 6 3s for leaves, you put all 6 3s into your stem and leaf display. So you always include repeat values as well. But you arrange them in increasing order. Now the book always does this in 2 steps separately. So they'll actually create their stems, they'll list all the leaves, and then they'll create another step where they actually arrange them in order. You can do these 2 things at the same time. So you can like go through and like circle all of the 120s and then just arrange them in order right off the bat. That way you don't have to rearrange or do an extra display off to the side there. And that's what I do generally. I just arrange them in order as I go. So that way I don't have to do a whole complete separate step. And then the last thing, combine a key, or provide a key. So once you have your stem and leaf display created, make a key that tells you what or how to read that display. Does the line cut off at a decimal point? Does it cut off at a 10, 100, whatever? So is it 7.6? Is it 76? Is it 760? So you have to put something with it to show how to read it. Okay? So here's a quick example. These data represent the response of the 20 female AP Stats students to the question, how many pairs of shoes do you have? And then we construct a stem plot. Okay? So here are the answers. We have 20 different students, that's how many pairs of shoes they have. So if I wanted to create a stem plot, my first thing would be to create my stems. So I have 2-digit values all the way throughout, ranging from 1 as the smallest and 5 as the largest. So my stems are going to be 1, 2, 3, 4, and 5. And again, at this point right here, I could have said 5, 4, 3, 2, 1. You can do it in any order. This is just usually the easiest to read. All right. Once I do that, I'm going to do this the way the book does it, so you can kind of see what that looks like, and then I'll show you kind of the combined version as well here. The next thing they do is add the leaves. So they say, okay, this is 10 to 20 essentially. So in my set here, what are all the leaves that I'm going to create? So there's 13, there's one of the 3s, 13, another 3, 13, another 3, 15, there's a 5, and 19, there's a 9. They just go through and grab them. 10 to 19, here are the values, 13, 13, 13, 15, 19. In the 20s, there was 26, 26, 24, 22, 23, 23. So they're just putting the leaves in here. All right? So this tells us where they are. Now they're going to arrange them in ascending order. So from here, they just take those leaves and rearrange them. So instead of 9, 3, 3, 3, 5, we start with the smallest and work up. 3, 3, 3, 5, 9. 2, 3, 3, 4, 6, 6, and so on. Now, one thing to note, kind of like with the dot plot, we said make sure all your dots line up correctly, right? Same thing with the stem plot, except now we have to measure vertically. So when I draw a vertical line through, I should be passing through all the points lined up in a nice, neat pattern. If I don't do that, I could have a set that has 5 values look bigger than a set that has 6. So make sure as you arrange those leaves, you are lining them up with what's above and below all the way throughout, so that the length of the bar is what we can focus on, not having to do individual counting inside. Okay? And then the last thing, always put a key. When you look at this stem and leaf display or the stem plot, a 4, line 9 represents a female student who reported having 49 pairs of shoes. Okay? So give it an idea of what the actual values mean. Now, as far as you guys creating stem plots, you do not have to do both of these steps. You can go straight from having your stems to here by simply arranging them as you go. Pick out which ones you have and then just put the smallest one first and work your way up. So this is an added step I don't do. The book will have you do it, but you don't need to do that as far as working all that stuff out. Okay? Last thing, splitting stems and back-to-back stem plot. Okay? What we mean by split stems, there might be times where I don't want to go from 10 to 20 and 20 to 30 and so on. There might be a large amount of data within each of those classes. So instead, I might split, and instead of saying 0 to 10, I might go 0 to 5 and 5 to 10, 10 to 15 and 15 to 20. So I might split them by 5s, and then that kind of divides up the values here. Back to back just means once you create a stem plot to the right, you can do the same thing with the second set of data to the left. And you just go from ascending order from right to left. Okay? Always have a key so you know how that looks. On your way out, I have a worksheet for your assignment today. I did not get a chance to staple these. So it is 2 pages. Make sure you don't lose the pages. You can just hold it.
Gracie Harvey, please come to the front office. Gracie Harvey, please come to the front office.
Did I get you?